Thank you for reminding me. Okay, entonces x squared over 16 plus y squared over 9 equal 1. Oh, good. I see in the right hand side 1. That's me. Que this equation is expressed en esta. 4. Entonces, what is the question? The question in this problem always do the graph. Do the graph. Always. Ese question. Entonces yo identify. Oh, es el X. How you identify que es el X? Well, because you see in the equation x squared and y squared. And the mathematical operation in between these, it doesn't matter the coefficient 16 or 9 x plus. Something like that, automatically you see que es ellipse. Parabola and hyperbola, different, but I analyze in your moment, no now. Okay, now you take who is A and who is B. Look in the equation. Well, the equation is, in general, remember, is x squared over a squared plus y squared over b squared equal 1. Or, be careful, x squared over b squared plus y squared over a squared equal 1. And how do you know who is A and who is B? A is the bigger. So you take a squared is 16 because 16 is the big number. It's greater than 9. Therefore, I put the arrow, A is 4. Square root both sides. And you take always the positive solution. Never negative because it's distant. And likewise, B squared is 9. Therefore, B is 3. Entonces now immediately I saw, wow, A que es 4, que A squared is 16, is associated with the X value. Therefore, my graphic look like that. No like that. Our ellipse is horizontal, no vertical. Because the big number is associated with X. Everyone follow me? Everyone follow me? Do you understand this idea? Okay. This is super important. This is super important. Now, I saw also que C is a square root A squared minus B squared. I copy the formula. Remember, the formula is A squared. I remember one formula, no? If you want to determine something, you isolate. Move B, subtraction, apply square root both sides. Entonces actually is square root A squared is 16 minus B squared is 9. 16 minus 9 is 7. It's radical 7 is irrational number. To have some idea how it look like, you put in decimal approximation at 2.646. Exactly decimals. Give me 3 decimal places. One more important thing we need to know. We need to know the center. The center is obvious que es located at the point 0,0. Why? Because I don't see any translation here, any shift. So you see x minus 2 squared something divided by 16 plus y minus 3 squared over 9 equal 1. So we have h and k. Pero no, we have no h, we have no k. Therefore, the center is located at the point 0,0. Now, with this information, are you ready? We are ready to do the graph of this. It's doing. Okay. I don't know. Do we have a graphic? Yeah, I suppose yes. Image, my device, none. must be here. Rectangular continuation. So let's do it by hand, like a kindergarten, guys. Okay, and after I double check it. Okay, what about the vertex? Well, the center is clear. The center is 0,0. There you go, center 0,0. What about vertex? Let me use in red color, vertex. Well, the vertex, I know that my ellipse is horizontal and the distance is 4. Oh, it says here 4 to the right and 4 to the left. The vertex located at the point 4,0 and negative 4,0. Cool. One more thing important we need to find. We need to find endpoints of minor axis. Okay, get minor axis located here in the y-axis. And the distance is 3 because B is 3. Look at that. This is the endpoint of the minor axis. The endpoint R is 0,3 and 0,9. Boom. Almost. I can imagine my ellipse. However, we have the information about foci. Very important, very important. Foci always is located on the major axis. At what distance? And this distance is 2.6 something. Using my imagination, 2.6 is approximately here. It's a one foci, 2.6 is another foci. So basically we have vertex 1, vertex 2, endpoint of the minor axis is this, endpoint minor 1, endpoint minor 2, and we have a foci que is foci 1 and foci 2. I call 1 and 2 either way. Now my ellipse look like that. I suppose, using my imagination and my common sense. Not good by hand, because I am doing using the pen, you know. However, you see elegant now in Desmos. Boom! Final answer. Do you understand very well the idea or no? In example 1. Yes, Sergio Medina. Say yes. Sergio always help me. Okay, no problem. Because now to double check in this job, because I want to get 100 points in this test. Because the professor said it's easy, the test 4 is easy. I go to Desmos. I go to Desmos. I go to Desmos. Okay, let me try to share the screen. Don't worry for this script because I want to send the link today by email. Okay, there you go. The name is Conic section. Do you see Desmos now or no? This script contains a lot of examples that we are doing today. No, a lot of the majority of them. For example, example 1. Boom. Do you see that? X squared over 16 plus y squared over 9 equal 1. And you click here, bam, and you see our ellipse. But you see our ellipse without point. And this is not good answer. However, you go here to the top part of the script and you declare, for example, A is 4, no? A4. You click here, A4. No problem, A4. And B is 3. And you enforce it to be 3. 3. What's going on with the keyboard? A ver. Ajá, sí. Okay. And H and K are 0 both because the center is located in the origin. 0, 0. Don't care P because P is for parabola. P is for parabola. And you classify here the different conic sections that we have. Horizontal ellipse, vertical ellipse, parabola, blah, 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 blah. In our case, we have horizontal ellipse. We click here. Hey, wait a second. I did wrong, no? B3. Ah, sorry, AF4. Mistake, carajo. Bon, but let me again. This is my elementary graph without point. However, when you click horizontal ellipse, bah, you see, look. Center, 0,0. Vertex, 4,0, negative 4,0. Endpoint of the minor axis, 0,3, 0,3. Foci, remember, it's a rational number, radical 7,0 and negative radical 7,0. And you see in different color. For example, in the purple color, you see the axis, the semi-major axis. In red color, you see the semi-minor. In the other color, I don't see very well, the focal length. So you are doing by hand, and of course you check it using this. Cool? Any problem? You using this script I prepared for my turn. Okay? And you can, change, modify. Inside this, we have a lot of formulas that allow us to compute quickly this point, right? I want to show you in detail, example by example. Let me go again to the whiteboard. The example 1 was easy or was complicated? Was easy, eh? Okay, because I want to erase everything. Do you see whiteboard or no? Do you see? Tell me, guys. Okay, Emily D. Example 2, Emily. Wow, what the hell? Look at that. This is 25 x squared plus 9 y squared is equal 225. I don't understand very well this example, but the problem is that the right hand side is no 1. In other words, this is no standard. No standard. So now I need to put in a standard to analyze. It's super easy. You divide it by 225 the entire equation. And you are doing by hand, calculate it either way. You divide 225 divided by 25 is 9. Well, no, actually it's 1 over 9. So x squared over 9. So the operation that I'm doing is 225 divided by 25 is obvious 9. Pero 9 in the denominator part. Likewise, 225 divided by 9 is 25. And 225 divided by itself is 1. Boom! Standard now. Do you see the operation? We are doing this every day. Right hand side must be 1 to start the analysis. Entonces, who is a square and who is b square? Who help me? Who is a square and who is b square? No, nobody understand How select A square and B square? Aha! A square is 25. Remember, the only thing you need to remember, you take the bigger number, que es 25, and associate with A. A is a bigger, B is no, it's a minor. Therefore, A alone is 5, and B alone is 3. Okay, so my next question is, how look like our ellipse? Look like that, horizontal, or look like that, vertical? What do you think? Vertical, because the big number is associated with the y. Therefore, the major axis is located in the y, or parallel, not necessarily coincident. Parallel or coincident. In this case, yes, it's coincident. Do you understand this elementary idea? This is the clue to little by little understand the section one. Okay. So now, well, let's compute the focal distance, que es C. C is equal to square root A square minus B square. But A is 25 and B square is 9. And this is 16. And the square is 16 is 4. Wow, nice. Okay, ready. So now we are ready to do the sketch of our conic section by hand, at least. Some example is easy. Let's do it by hand. And verification and this one. I know it gets complicated because the number is horrible. Decimal or irrational number. So you skip the graph by hand, and we're doing directly in decimals, and you make a copy like an image of your word in decimals. Okay, now the vertex. What is the vertex? The vertex is located in the major axis. Yeah, I know that the major axis lie in the y-axis. The vertex, one of the center first. Center first. Center of this ellipse is located at the point 0,0. Boom, here. And the vertex is located obviously vertex. It's vertical, but it's a vertex. On the y-axis, what distance? 5. Here. 1, 2, 3, 4, and 5. That point is the point 0,5. And that point is 0, negative. And the vertex 0,5 and 0, negative. Cool. Now what about the endpoint of minor axis? Let's look at it in the x-axis. Now what distance? 3. So 3 here. This is 3,0 and minus 3,0. 3,0 and minus 3,0. Cool. And what about foci? Foci, remember, is the word in plural for the focus. Focus is only one. Foci is plural. But we have 2. In the ellipse we have 2. Foci. It's always located on the major axis. So on the y-axis in this specific example. At what distance? And the focal distance is 4. In this example. Now for a 1, 2, 3, 4 here. This is the point 0,4, and this is the point 0, negative. This is foci, for example, I call number 1, foci 2, vertex 1, vertex 2. This is the end point of the minor axis 1, and end point of the minor axis 2. Entonces, our elixir, let me use another color, because not always black in this example. Passing through this point, and the focus always lie inside the elixir. Wow, not good, my stage. The important thing is, some people doing the like that. No, no, never. You know, well, no, this is possible, but the elixir never have a corner point here. It's a smooth curve, and the parabola, and the hyperbola. Never, never. I said one peak like that. No, no. It's a smooth curve. Okay, okay, okay. And that's it. Yeah, I suppose yes. We are doing the example. Now, see, I'm doing by hand. Never we are doing by hand. And in the test, you are doing in decimals, no? I'll show you. Okay, that was example one. Okay, this is history. And this is the example one. Okay, I did before. Now let's move on to example two. But intentionally, I copy, and the original way it is given, no standard. Because I know very, very well, algebraically, this expression is equivalent to another expression. Okay? Entonces now, in the test, of course, in the test, you are doing some algebra. I need to see the piece of paper. However, you double checking, you put in the way it is given. Okay, entonces in the way it is given, I know que A es 5. And B is 3. Cool. And the center is in the origin. H and K are C. Wait, sorry. You click here to see the elixir. Wow, it's clear, it's very cool. However, I have no point. However, you classify like a vertical elixir. Bang! And you see the point. Again, center 0, 0. Vertex 0,5, 0,-5. Endpoint of the minor axis 3,0, minus 3,0. Foci 0,4, 0,-. In this elementary example, we start at the beginning and the number is easy, no problem. However, in another more complicated example we see today, maybe the number is horrible. Now, you're using this, you always get the answer. Okay? Okay, no bad. I understand. I don't know if you understand. You understand or not? So far, no? So far it's clear or not? So far it's clear or not? Conic section. Yes. Martin Sepe. Let's see one more example. This is a little bit more complicated. Example 3. And example 3, the question is giving, I need you are doing the graphic. It's something like that. $25. It's a 5. My we are 5. Equal. Cool. The right hand side is 1. That means that this equation is already expressed in standard. Nice. Okay, I don't need to touch. Only looking. No algebra. No extra additional algebra. No. Okay, entonces I see something weird because I see 3, -3, and +2. Entonces, where is located the center of this ellipse. At what point? At what point is located inside? H, comma, K. The only thing that you need to be careful, remember, I compare to understand very well. This is my equation. Well, either way, it's not important. This who is A, who is B. It's not the problem now. Suppose this is B. The K letter is associated with the Y, and the H letter is associated with the X. So you, in your mind, this is X value, and this is the Y value. You compare this equation and this equation, comparison. Well, I can find clear like a water. HS3, look, HS3, okay, HS3, and K, wow, complicated, positive, negative. The reason is K is negative. And you plug in this negative here in this equation, we have double negative, and double negative becomes conclusion, guys. When you want to write the point of the center, of course, we copy exactly the opposite sign you see in the equation. In the equation is negative, you put positive. See, in the equation is positive, you see that. It's not new for you, because when you study circle, you see that part. It's not new. The center is located at the point 3, negative. Cool. Okay. So now I erase that part. Now identification. Who is A, who is B? Or at least who is A squared and who is B squared. Remember, the most important, A is a big number. The major, A squared is 25. Therefore, A is 5. B squared is 16. Now B is 4. This is my classic equation. How it look like this ellipse? Horizontally or vertically? Horizontal or vertical? Please help me to understand this. A vertical, Emily T. And Emily, this is the center. This center, cum, is located at the point 3, negative. Cool. What more information we need? We need the focal distance, no? Focal distance is C. It's a square root A squared minus B squared. It's a square root 25 minus 16, que es 9. And the square root 9 is 3. Okay, so that distance is 5. Look, that distance is 5. That distance is also 5. That distance is 4. Okay, the distance of the minor axis. And this distance is 3. But the focus always lies here, S3. Focus here and focus here. Okay? This is super roughly sketch. But don't worry, because we are doing clear now, specifically. And you find in Desmos, okay. In Desmos, I want to write, but no after. Let's do it in Desmos. Vertex, 2 vertex, endpoint, minor axis, 2 endpoint minor axis, something comma something and something comma something, something comma something and something comma something. We go to Desmos, you see in Desmos, and copy that. Okay, and one more, the fuzzy, we have 2 also. Okay, and that's, yeah, I guess so. So the information that we need is ABC and H and K. End the story. Let's do it. Let's move now. Okay. Well, this is this one. This is the example, the last example. I put on enable this and this. No? Example 3 we're doing now. This is example 3. Look. 16 and 25. Yeah, -3 and positive. Exactly. And copy right. Bang. This is my elixir. Of course, the center of this elixir is not in 0, 0. No, 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 no. We determine get 3, -2. That makes sense. Look, 3 and -2. Do you see this one, no? Yes or no? Aha, cool. Thank you, enough. Okay, no, wait. You help me. A is 5. B is 4. In this example. H is, I don't remember, 3. Okay, I don't remember, a -2. You can move the handle, but sometimes it's not comfortable to get exactly the same value that we need. No? Ah, I got it. And forget about P. P is for the parallel. Okay, now ready. In this case, we are talking about vertical elixir, yes or no? Because A, K5 is associated with the Y. Boom! And this is our elixir. Complete analysis of the all point. Let me try to understand because I am confused. Center, 3, -2. That part I understand. Vertex. Vertex is located at the point 3, and 3, -2. Why? I don't understand why. Because it's 5 unit. A 5 unit over and 5 unit downward. So you will have in the point 3, -2. And we moving vertically 5 unit over is -2 plus 5. And -2 plus 5 is +3. And downward is -2 minus 5 is -7. Wow, I understand now. Okay, now in the minor axis, the distance is B is 4. Entonces you increasing to the right or decreasing to the left, and you keep the same Y component. You see que es -2, but where come from this 7? It's 3 plus 4 is 7, and 3 minus 4 is -1. 3 minus 4 is -1, yeah. Subtraction of 1, you put the sign of the bigger number. And likewise happened in the fossil. In the fossil, the distance is 3. 3, but it's over and downward. Remember, important idea. The fossil lie on the major axis always. Now is -2 plus 3 is +1, and -2 minus 3 is -5. Now, for me, now it's more clear. Okay, guys, or no? Okay? Elise is easy. Okay, let me summarize this example. I go again. Do one more, and let me finish my problem, no? Okay. Okay, vertex is located at the point 3, 3. I saw something like that in there. 3, 3 and 3, -7. At this point is 3, 3. And this point is 3, -7. Because this point is the center one is 3, what about endpoint of the major? What is this guy? Okay, is 7, comma, -2. You see it keep the same y component, and increasing the x component is 3 plus 4, because 4 is b. And b, right, positive, and left, negative. Entonces is that point que es -1, comma 2. So you don't remember, no problem. You go back to decimal illustrate very well. So now this point is negative. Well, this point is 7, -2. Oh, no paréntesis, double paréntesis. No. Only one. Okay. And -1, comma, -2. This is -2. Sorry, I make a mistake. One more time. And the fossil lie in the y-axis. The distance is 3. 3 up, 3 down from the center. Entonces el fossil is located at the point 3,1. Is that fossil 3,1, and this fossil is 3, -5. 3, -5. It's a little bit before this 3, -5. The vertex is -7. Fossil is -5. Okay. I suppose I understand very well, no? Oh no. No? Okay. Be careful with the complicated part, que actually not complicated, is do the graph in detail, because I need detail. If you are doing the lecture like that, 0 for you. Good. Lecture like that, 0. 0 for you. Okay, I need details. Detail is any point. Center, vertex, endpoint, minor axis, fossil. Okay, let's do one more example. This is more complicated, but don't worry for this, because we are doing using decimals. But the problem is example 4 now. Example 4. In example 4 we have, wow, 3x squared plus 7 y squared plus 6x minus 28y plus 10 equals 0. Wow, what the hell is that? I don't understand anything. Okay, the most important for you is immediately you understand que es el x. Why? Of course, no es present standard. It's a general. This is the name of this is general form. General form, general. Is when the right hand side is 0, you move everything to the left, and you organize in the same order of the degree. 2 degree in x and y, 1 degree in y and x, and no degree, 0 degree. This is elixir, but what is the clue? Okay, give me identification. That's elixir. You have a number x squared, you have another number y squared, and the rest I don't care. So x squared, y squared, not necessarily the same number. Si it's the same number, 3, 3, or 7, 7, it's a circle. Okay? However, different number is elixir. I have no idea si it's vertical elixir or horizontal. The rest of number give me information about the motion of the center. See, this number is missing. No 28, no 6. It's because the center is located in the 0,0. However, in this case, no. So the responsibility of this part is the translation, the transformation of the vertex. Okay? But you don't worry too much. The most important is you identification. Wow, it's elixir. I like that. So now we have one doing now organization to do our best to manipulate in order to put in a standard in a standardized way. and you group in somehow the x part. Listen to this, 2a. I copy, but before you copy, I can see that 3 is a common factor, and between 3 and 6, I can factor out 3 plus 2x, because 3 times 2 is 6, no? I factor out my mind, this is 3, and this is 3 times 2, no? The 3 factor out, the common, greater common factor. And you complete the square, put the artificial magic number. Okay, you see after, no important. I finish the x part, and the y part, look, is this and this. And you see that 7 is a common factor, because I know very well that 7 times 4 is 28. And you copy y squared minus 4y plus another box. Close the parentheses. This is trinomial. I need to complete this trinomial in order to put like a perfect square trinomial. And in the right hand side, I move it 10, like a minus 10 plus 2 box. And inside the box, I put the specific number to help me to simplification of our expression. So what's the strategy? What's the idea? It's easy. It's the formula of the complete square gets b over 2 squared. In our specific, first, b is 2. 2 divided by 2 is 1. And 1 squared is square and 1. The magic number is 1. And this, no. And this is 4. And 4 divided by 2 is 2. And 2 squared is 4. Oh, it's a coincidence. So 4. Do you understand very well where I come from? This 1 and this 4? Or no? What's confusing for you? Yes or no? Always is the same. Clear. Okay. Now, you put artificially this 1. You put artificially this 4. So I need to put similar number here in order to keep the equilibrium of the equation, no? But actually, it's not 1 and 4. No, be careful, because this 1 is multiplied by 3. So actually, it's 3. And this 4 multiplied by 7 is 28. It's 28. So it's 28. Wow, it's 28. Be careful. When they encircle, you know, it's easy because we have no coefficients here, or the same coefficients. In this case, no, it's different. And you keep in mind, you put artificially this 1 inside the parentheses, but actually no 1, it's 3. And this 4 is no 4, it's 28, because 4 times 7 is 28. And now you keep this 3, break down, and you factorization. I guarantee you 100% that this trinomial is perfect square. And where I come from this 1 is the square root of this guy. Where I come from this x is the square root of this. You expand this, you get that. Plus 7. Here is y. Square root this is square root 4 is 2. And this is minus. How do you know it's minus? Because this sign is negative. So in the trinomial, we have two signs. This sign and this sign. This sign is positive, I copy that. This sign is negative, and always the second sign in the perfect square trinomial is positive. I guarantee you 100%. Si es negative, this is no perfect square. Actually, this number is always plus, never negative. Okay, now, I combine. This is 28 plus 3 is 31, and 31 minus 10 is 21. June. Almost, we finish. Now I need the right-hand side 1. You divide by 21, everything. Okay, and 21 divided by 3 is 7. So x plus 1 a squared over 7 plus y minus 2 squared over 3. I go from this 3, 21 divided by 7, no? Equal in the bottom, of course, in the denominator, equal. Cool. This is my equation expressed in standard. Exactly I expecting, I dream for this moment. Okay, and unbelievable, this equation is 100% equivalent to this horrible equation. 100% they are the same. I want to prove, because in decimals, to verification this idea, I put the horrible equation. I put the other equation, and you see get the same elixir. Okay. This is the beauty of the mathematics. Okay, now, I need to identification center. Who help me with the center, please? Look in this standard. The center of this elixir is located at the point. At the point. Are you sleeping or you are awake? Okay, where is my question is -1,2. Everyone is agree or disagree with this idea? -1,2. Remember, it's H and K. H is -2, K is positive. Remember, opposite sign in the equation to the point. Opposite. What about A squared and B squared? Who is this guy? Look in the equation. No mathematics. Only use your eyes. Who is A squared? Who is B squared? A7, A squared, sorry, and B squared is 3. Therefore, automatically I know that A is radical 7. Of course, it's a weird number, no? But I don't care. And B is radical 2. Immediately, I put in my calculator, I compute the decimal approximation for that number, no? It's a 2.645, using 3 decimal, guys. Because the approximation for the decimals is in 3 decimal to verify everything. 1.732. Okay. I don't care. This is not important. The important is what is the orientation of this elixir? Is horizontal or vertical? Horizontal. Emily did say horizontal. The reason is horizontal like that. This is wrong. It's because the big number gets 7 somehow is associated with the y. Okay? Now I need to compute the rest of the information is the fossil. And we are ready to put together everything in decimals. The formula for the C is equal to square root A squared minus B squared. This is square root A squared is 7 minus B squared is 3. Oh, this is 4. Radical 4 is 2. I like that. So the information, okay, so far we have roughly, is that the center is located at the point -1,212 here. Our elixir look like that, horizontal. This distance is the horrible decimal. This distance is this horrible decimal. And 2 is no horrible, is the focus. Here, this distance is 2. And this distance on the other side is also 2. Okay, because we expect something like that. Cool? It's doing. You have no question, no? Do you understand very well the organization? For the completed square, I promise in the review packet we practice more examples. Okay? And you practice by yourself and the homework online. Okay, let's move on to see the last example. Wow. Sorry, the last example. This is the last example. Last of the elixir. Okay. Example 4, no? I have more example. You can see it by yourself. Okay, example 4. Example 4 is this. Wow, we are very well. Look, 3x squared plus 7y squared plus 6x minus 28y plus 10 equals 0. Wow, what the hell? I plot that. Boom. It's similar to analysis we were doing before. In this case, a radical 7. How do you put radical 7 here? The fantastic way, you using the keyboard of the dictionary to delete that number here, and you put a square root 7. And automatically they put the fantastic approximation using a lot of digits of the radical 7. Likewise, MB is radical 3. No? Cool. Now, what about H and K? H is -1. Yeah. And K is, well, it's a whole number you can move. If you want, it's 2, positive. Okay, positive 2. Okay, I delete. Positive 2. Okay, ready. Remember, P is for the parabola. So the classification was the horizontal axis, yes or no? Okay. And this script compute everything and plot that. Whoa! Look at that. Center, -1,2. Vertex, it's a weird number. I suppose que, well, it's a weird. Because remember, A and B are irrational. The only guy gets rational is the focal distance. Que was 2, no? And from this point, you move it to the right, you have -1 plus 2 and positive 1. And -1 minus 2 is negative. You follow me? You follow me? I suppose that you have the most important tools to understand ellipses so far. Okay, come back to the word. Super cool. And we are using this script guide because the complicated number is horrible. Switch it to the whiteboard. Now let's discuss in parabola. Parabola is super easy, super easy. But you need to understand clear the theoretical part of the parabola. Parabola is a curve. Of course, is the open, not close curve. And we have 4 kinds. Anything that the student don't understand very well. We have 4 kinds of parabola. 4 kinds. 4 kinds. We have, for example, this kind of parabola. But let me use another color. Okay. Or like that. It doesn't matter. The point is not important. This parabola, this and this together is horizontal. Because open to the right or to the left. What depending? Si open to the right or to the left? Bueno, depende en one parameter que es the only parameter que have the parabola que es P. When the P is positive, and when the P is negative. And who is P? Well, the formula of the parabola is this kind of parabola is y squared equal 4p x. This is the formula. Entonces, the parabola is different. Remember, recall, ellipse, we have x squared plus y squared. One number here, one number here. Not necessarily the same. However, parabola, no. Parabola is, you have y squared and x no square, linear, or x squared and y squared. So now when you have that situation, it's the horizontal parabola. However, so you have this kind of parabola or this kind of parabola, this arrow indicate, guys, that this continues forever, and this is vertical parabola. And the equation is x squared equal 4py. So x squared es vertical, y squared horizontal. P es the parámetro que identify. When the P is positive, the vertical parabola open outward. When the P is negative, the vertical parabola open downward. And the horizontal parabola, when the P is positive, open to the right. And when it is horizontal and P is negative, open to the left. That's it. No, that's it. This is just the beginning. The identification, what kind of parabola. Remember, we have 4 kinds. Left, right, horizontal, up, down, vertical. Now, how do you know? Because in the vertical, x is squared, and the horizontal, y is squared. And that's it. No. We have more information, important information that you need to know perfectly. Okay, suppose to simplify the thing. Okay, we have one horizontal parabola, like that. The same conclusion I want to explain now is valid for the vertical. Just important point, important. This point is super important. It's the point in which the parabola turns in. O sea, es, suppose que this is the vertex. The name of this guy is vertex. O sea, in the parabola, we have no center. Center is elixir or hyperbola. No center. We have vertex. In my opinion, is the most important point. The vertex. How you determine this, I want to explain right now. Okay, now we have foci or focus, only one. This is the focus. Focus is in this axis here. Okay, by the way, okay, I need to explain a little bit. It's a point, and the distance between the vertex and the focus is P, the same P of the formula. Suppose, hypothetical, que the equation for this parabola is y minus k squared equal 4p x minus h. Entonces hay identification. Wow, es horizontal because the square is y. And the vertex is located at the point h comma k. Okay, que es this. This is the famous point h comma k. And what about the focus? Well, focus is inside the parabola. So the focus, suppose that the parabola open this is the focus. Open this is the focus. Open this is the focus. Open that, this is the focus. Never the focus is outside. No, inside. Okay, now, when the distance in the same axis, in this case the x-axis, but in general, no. This distance is p. So this is the formula. Suppose I want to find this. This is h plus p, no? Comma k. But you don't care for this formula because this formula in Desmos we can complete. Important for you is identify what kind of the parabola we are working. Horizontal. Where is located the vertex? Look in the formula. It's h comma k. An example, numerical example, you see. This is just theoretical. One more, guys. We have two important axes. Is look. Put another 4. This is this axis is the symmetry. Axis of symmetry. Axis of symmetry. Why? Because it's the axis that split the parabola into equal parts. Suppose another parabola like that. This is the axis. Suppose another parabola like that. This is the axis. And the axis symmetry, bueno, is always a horizontal line or vertical line. In this case, horizontal line. And the equation for any horizontal line is y equals something. In this case, y equals 0. But in general, no. In general, is y equal k. Because the position is supposed to, the origin is not here. But it's okay. Y equal k. And we have another important line, another important line. Okay, directrice. Directrice is in this case a vertical line. Can have the same distance from the vertex. So you focus in the vertex. I plot that on, and P to the right is a focus, and P to the left is directrice. And this vertical line, the equation is x equal, well, entonces h minus p, because this point is h comma k. You're subtracting p to the left is h minus. This is directrice. Important. So when you plot the parabola, you need to plot axial symmetry, directrice, vertex, focus, and 2 more points. Super important point. The name of this point is endpoint, because it's 2 in plural, of focal diameter. And what is that? In the focus, you are doing the line, and this is the focal diameter. And this gives me the information how wider or how narrow is my parabola. So suppose there's one parabola like that, boom, and this is the focal, and this is the focal diameter. Suppose another parabola like that, boom, this is the focal, and this is the focal diameter. And the endpoint of the focal diameter is this point and this point. In our sketch, is this point and this point. And how you determine it? Super easy. This distance is 2p. 2p. And this is also 2p. And 2p plus 2p is 4p. Exactly the coefficients you see in the equation of the parabola. This distance is 4p. And p give me information in what direction open, no? Si it's positive to the right, si it's negative to the left. In the case que we have horizontal parabola. So now endpoint of the focal, super easy. You put the segment line. By the way, this segment line is called focal diameter. And passing through the focus, of course, and touch the parabola and this point. And the distance is 2p from the focus. Okay, I understand. Let's see example to clarify this idea. Example to clarify the idea for the parabola. No more secret in the parabola. Any question? No? Okay, let's do in, I don't know, 1, 2, I did 1, 2, 3, 4 problems. I did 4 problems of the conic section. The easy elementary to the more complicated, you need to complete the square. Example 1. Example 1 of the parabola. The equation is given, x squared equal ay. Okay, given that, I need to do the graph. Okay. Number 1 step, classify what kind of parabola we have in this example. ¿Es horizontal o es vertical? What do you think? ¿Es horizontal or es vertical? Guys, this is extremely important when you take calculus. You need to know conic section in detail. The teacher can explain calculus 2, basically calculus 2. Es vertical. Emily D say it's vertical, professor. The reason it's vertical is because x is squared. This is the clue. X is squared, y not squared. And what direction open? Open to downward or I don't know. Well, I don't know. So I suppose the equation look like that in the standard, no? 4px, 4py, sorry. And new identification, wow. It's because 4p is equal to a in our specific example. See, 4p is equal to a, it's because p is 2. And 2 is positive. Si es positive, entonces my parabola open upward. Sorry, up. Okay, two identification. Remember, we have 4 kinds. Vertical, horizontal, and so you select one. Oh, vertical. Okay. But in what direction? Up or down? You analyze P. The sign of P. P is positive. Up. Cool. Okay. Entonces now I discover also that the vertex of this parabola is 0,0. How do you know that? Because when you have translation, the equation is a little bit different. It's x minus h squared equal 4p parenthesis y minus. I don't see any subtraction or any addition. It's because h and k is 0 both. Nice. It's the first example. Everything is easy in the first example. Okay. Now. IP is given. Okay. There's one more information we need. Let me try to do my best. Yeah. Let me try to do my best. By hand, as always, to illustrate. However, in the real life, we end it. And then, okay, there you go. Let me enlarge a little bit more. Okay, I know, I discovered that the vertex is a 0, 0. I know also that my parabola open like that. Wow. No. Okay, one more information we need. We need focus. The focus is, okay, this is 0, 0. The focus is inside the parabola here, and the unit is P. This is P. Therefore, it's 2 here. This is focus. And the point is 0,2 is the focus of the hour. Okay, one more we need the famous, let me try to do in this order. The endpoint of focal diameter. Endpoint. Okay, you know is to be. Okay, what's the idea to determine this? So far, we have the family of the parabola. However, I need to identify. Look, see my parabola. This is the vertex. This is the focus. But you put 2p here and 2p here, and give me the famous endpoint for the focal diameter. And I know then how wider or narrow is. Suppose the p. Oh no, p actually is 2. And then 2 times 2 is 4. This distance is 4, and this distance is 4, and 4 plus 4 is 8. Exactly the same you see at the beginning. Okay, for P is 8. Entonces, in the same direction of the focus, I travel 4 units. 1, 2, 3, 4. Bam. And 1, 2, 3, 4. Bam. That point is the point 4,2. And this point is the point negative 4,2. In our parabola, I suppose, using my imagination, they look like that. Smooth. Cool? You see more clear on this one. That's it. No, please. Don't forget the famous The famous axis of symmetry. Es the axis que split the parábola in two equal parts. Symmetric, axis of symmetry. And by the way, it's coincident with the y-axis, because the equation is x equals 0. And we have directories. We try directories in green color. The directory is the same distance from the vertex downward in the opposite direction. Es negative. This line, que normally is you put like a dotted line, because it's auxiliary line, is the y equal -2, is the directrix equation. And that's it. And the story. I finished every detail. Detail is vertex, boom. Focus, boom. Endpoint of the focal diameter, boom, boom. Axis of symmetry, and directrix. Done. And this parabola is open up. Y es vertical. Then question. But not good to this idea. I want to double check it, and that's possible. Because the professor prepared for us, your students, my students, is my priority, is okay. I don't understand anything. Is the no elixir anymore, no. Es the parábola. Okay, example 1 parábola. Look at that. Oh, it's easy. X squared equal AP. I put this long in green color. This parabola is wider, yes, I know. But you go here, and you declare, Come on. I don't see, yeah, sorry. I forgot to share. You know something, when I citing. Because I focus on the mathematics, I forgot the computer part. Okay, sorry. But you are my student que always help me to do the list. Okay, so now, do you see, I select, look here in the example, this application bring default example 1 parabola. Okay. I activate, but in order to find the point, the most important, I don't care A, B, it's not important. A, B is the elixir. I care only P, que P es 2. Cool. And what about H and K? Well, H and K is 0. 0 and 0. Okay, if it's too complicated, you put it directly here. Entonces, what kind of classification of the parabola? It's vertical, no? Vertical parabola. Oh, look at the vertex, 0, 0. Focus, 0,2. Endpoint of the focal diameter, 4,2, negative 4,2. Directrix equation is this dotted line, is y equal -2. Axis of symmetry line, x equals 0. Done. Any question? No problem. Okay, you help me now with the next example. But we go a little bit fast. Not necessarily do it by hand. You manipulate the algebra que needs to understand and classify, and after go to this. So at a piece of paper, you are doing the algebra accommodation to understand the most important features of the Conic section. And to do the graph, never we are doing by hand. Okay, suppose example 2 now. Do you see whiteboard? Or no? You let me know because I'm crazy. Yes, okay. Example 2 now is y squared equal 16. I change the flavor now. Number 1, identification. We have Parábola. How do you know que parábola? Parábola because y is square and x no square. Si both are square es el x. Entonces es, pero what kind? ¿Es parábola like that o like that? ¿Es horizontal o es vertical? Horizontal. Martín Céspedes. Say que es horizontal. And the clear identification when the y is square is horizontal. In order to find what direction open, right or left, I know the formula. And I know que 4p is 16 in this specific. About 4, p is 4. And 4 is a positive number. Therefore, open, open, open to the right. Nice. I like that. Okay, so now the vertex, one more time, is at 0,0 because I don't see H, no K is missing. Okay, so I need to find the focus. Okay, P this time, so my parabola, do roughly sketch by hand, understand the behavior, 0,0, open in that direction. And this distance P, in our example 4, that point is then 4,0. Makes sense, right? And directrix is lying like that. Okay, it's x equal minus 4. Opposite direction. And the endpoint of the focal diameter, that was 4,0. Is 4, something and 4, minus something. And the distance is 2p. And the distance is 2p. And 2 times 4 is 8. See, this point is the point 4,8, and this point is the point 4, negative. And the distance between two endpoints is 16, exactly the same. We see at the beginning 4p is a plus a. And so the endpoint of the focal diameter are 4,8 and 4, negative. End the story. I do quickly one analysis by hand to have rough idea. How look like? Okay, now, why not? Go to Desmos and doing that. I suppose it's the last. No, we have 10 minutes. Okay, one more. Okay, Desmos now. Share screen to Desmos. Okay. This is Desmos. Let me delete the other example. Now we are doing example 2. Look at that. Oh, it's a horizontal parabola. The teacher will teach you calculus 2 appreciate so much that calculus 3. You know very well conic sections. He supposed que you need to know this. However, some good teacher make a quick review, not in detail like that, of the conic section. To say you suppose que you understand this. Okay, so what about the only parameter que we need is H and K, que es 0, and P, que P es 4, ¿no? P es 4. There you go. And you classify this parabola horizontal. Look at that. 0, 0, vertex, focus, 4,0, endpoint focal diameter, 4,8, 4,8. The entire focal diameter is 16 units. Axial symmetry is the line y equals 0, coincident perfectly with the x-axis, and the directrix is the line x equal negative 4. It's vertical. Super. You know, it's important because we have a family of the parabola, no? But how do you know how wider or narrow is the parabola, depending the focal diameter. Okay, depending the P parabola. Suppose I change the P. Look. Do you see how I change the parabola? Exactly the black color is the original parabola. Suppose I make a mistake to compute this. Oh, it's different. No. CPF4. Wow, it's a perfect coincidence. This is the beauty of mathematics. It's the exact sign. One more example. One more example. Okay, whiteboard. Do you see my whiteboard? I erase everything. Cool. Example 3. Example 4 we are doing next time. Okay, example 3 we have y plus 3 squared is equal minus 4 x minus 2. Okay, in that case we have translation. We have horizontal shift and vertical shift. Okay, no problem, I understand. And you compare this equation and this equation. Y minus k squared is equal to 4p x minus h. So this guy is h. This guy is k. Of course, with the opposite sign. And as we conclude clear, okay, the vertex of this parabola is located at the point, 2 comma 2 positive, comma negative. But what kind of parabola? Is vertical or horizontal? Is like that or is like that? In what direction? Is down or is left? To answer this question, you see, when the y is positive, when the y is square, is horizontal. Okay, so you discard that. To determine in what direction open, you determine the value of p. And you see that 4p is equal to -4. In our specific example, it's obvious que p is negative. Divided by 4, p is negative. Therefore, we are in front horizontal parabola open to the left. And by the way, this vertex is located at the point 2 comma negative. Okay? So I need to determine focus. I need to determine endpoint of focal diameter. Okay, 2 guys. Okay, so I prefer using the script decimal because the time is almost over. Number 1 and number 2, because it's a little bit complicated. No, the geometry maybe is confusing. Let's do it. Okay, share. Wow, here. Cool, I have that. Okay, erase everything. No example 2. Now example 3. Ooh, 3 minus 2. Why did I? Nothing I see. Oh yeah. Sorry. Es expecting, ¿no? Es expecting que the parabola is horizontal and open to the left. Because P is negative. Now P is -1. I go here. P is -1. -1. Ooh, too much. And K, H is 2. positive. Okay, is -3. Too much, negative. And we classify this parabola like a horizontal parabola. Boom. Oh no, no hyperbola. Parabola, horizontal parabola. Boom. Wow, wow. So I need to make a zoom to understand this because P is small p. Okay, now remember the distance is from the vertex to the foci is P. P to the left. So 2 minus 1 is 1. 2, that 2 minus 1 is 1. And -3 is 10 because the motion is horizontal. And this guy is 2p, and 2p in this direction. Entonces es -3 plus 2 es -1, and -3 minus 2 is -5. This is the focal diameter. Okay, this distance is only 4, no? 2 plus 2, 4. And this is the directrix. Is the line x equal +3. Look, because this is 2 plus 1 is 3. And the axis of symmetry split the parabola into equal parts. Is the horizontal line y equal -3. Y equal -3. Take a look. Next time we continue then another more complicated problem of the parabola and the problem of the hyperbola, right? I suppose que I start new section. What do you think about this chapter? Is easy or is complicated? I suppose que it's easy, but too many details, huh? Too much detail. Yes, easy, just a lot of steps. Yes, I know. Of course, in the test I put a complicated example, no easy. Okay, guys, too much. Enjoy your rest of the weekend. Don't forget me to send me everything. Okay, you are pending with me, no? Okay. I repeat, today is due the test on paper, and Friday the test online. Okay, guys, bye-bye. Have a nice day.